Hey guys, Buildzoid here, and today we're going to be taking a look at another DDR5 setup with Ryzen 9000. This time I'm finally trying out a Gigabyte 800 series motherboard. I'm also finally trying out a Gigabyte motherboard with a 6-layer PCB. All the 600 series Gigabyte boards I used with Ryzen 7000 series used 8-layer PCBs. So, yeah, that's kind of exciting. I did have to buy this motherboard because Gigabyte kind of like forgot that I exist. So yeah, big thank you to the channel supporters for making the purchase of the motherboard possible, as well as the CPU. I bought that as well. The memory kit that I'm using is a Kingbank Sharp Blade 2x24GB 6800 CL34 kit, and that was provided by Kingbank. So big thank you to them for providing the memory for testing. Now then, the main point of there's sort of two purposes. One, I want to test out this board, and I wanted to start in one-to-one mode because one-to-one mode tends to be a lot easier to work with, especially when like this 9950X, it's kind of terrible in two-to-one mode, but it's actually my best CPU for one-to-one mode. So, yeah, this was kind of the like easy option as far as I'm concerned. But the other thing I wanted to test was 24 gigabit MDI in like with trying to push the TRC lower on 24 gigabit MDI, because obviously I think like maybe a month ago I made a video about how like TRAS and TRC on AM5 CPUs behaves very strangely, and not at all according to JEDEC spec. Um, so yeah, I wanted to test how low I can push the TRC with some 24 gigabit MDI in one-to-one mode as just like a starting point. I'm also going to be doing that testing in two-to-one mode, but um, yeah, this is just sort of the like in one-to-one mode, especially on a new motherboard. I'm not going to potentially be dealing with a bunch of issues that two-to-one mode tends to bring up. Now, as you can see, I do have a fan pointed at the memory sticks. That is attached the usual way. I just have these super tall motherboard standoffs, and yep, I have them bolted to the middle of the board. It's worth noting that on this motherboard, the M.2 cover does actually block the standoff like right in the middle of the board. This isn't really an issue. The reason, so like I'm obviously just not using the M.2 cover in this setup, but if you wanted to use the M.2 cover, that hole is in the exact same place on the top edge of the motherboard. Like you could also just mount the fan on the top edge. I didn't do that because I didn't want the fan covering up the post code, which I just thought would be kind of awkward on camera. I'm pretty sure it would still be legible, because in person it would be legible. But yeah, I wasn't sure how the camera would handle looking at the post code through a fan, so I'm just running the board without the M.2 cover. But anyway, so yeah, that's how I like to keep the fan in place. Um, Now then, was there anything else? Oh yeah, and the fan is because I decided to push the memory to CL28 at DDR5 6400 because otherwise this would be a bit boring in my opinion. Um, and yeah, so anyway, here's the OS. It is still running Prime 95 right now because on the 16-core CPU, Prime 95's UI is not great for being able to tell if your like workers actually are running or error. Well, like if I stop the test, right, it will be really hard to see if any of the workers actually had any errors. So the way I came up with dealing with that was like I'll just run Carhu first for a day, then 6 hours of yCruncher VT3, and then I'll just run Prime 95 into the video and we'll stop it on camera because you can see right now all of my workers, I mean, all of my CPU cores are at 100%. That means none of the workers have crashed. Um, and yeah, and it's been running for just over 10 hours. As you can see, it started at 2306. It is currently 9:32. So it's like 10 and almost 10 and a half hours of Prime 95 at this point. So basically like 2 days worth of stress testing. And the reason I'm doing this is because with ADI, when I've been pushing, like where I've messed around with like pushing TRC low, I noticed that it would tend to error out very slowly. And that was also kind of happening or like very late. And that was kind of, I already got hints of that testing a lower TRC value earlier. Um, which I'll try pull up a screenshot. You know what? At this point, I'm just going to commit to this take of this video. um, I will just, and I'm stopping the workers. But yeah, like this is just one frustration I have with Prime 95, where it's like, oh, you have a 16-core CPU. I guess you don't want to know if all of your tests actually finished without erroring out. I can't see anything. Like, right? And it's like, oh, well, like try scroll down or something. You can't even scroll when it's like this. And so, yeah. So that's very frustrating, but anyway, screenshots, and it should be this one. Yes. Yeah, so you can see. And so this was really funny because there was no errors for like 4 hours straight. And then in the last 50 minutes, it just spat out 5 of them. And this was a TRC52 with an even higher TRP. Now, in the past, I usually ran much lower TRAS. Now, admittedly, with MDI, like based on my experiences with running MDI on Intel CPUs, it doesn't generally like running TRAS as low as ADI does. But yeah, I thought like, oh, maybe the TRP is too low or something. And like, so basically, like even on AMD, I wouldn't push the TRAS as low as I would as I do with ADI, or at least used to with ADI. But anyway, so I was like, maybe the TRP is a bit low or like, you know, something like that. So that was that run. And then there's the run we're currently on where you can see I actually have TRP even lower. It's at 34, which is kind of what I would expect for ADI, to be completely honest. So that kind of surprised me that that works. Maybe even 32. So yeah, though TRP does tend to have some variance stick to stick. So yeah, but anyway, so TRP 34, TRAS 126, TRC 58, whereas at TRC 52, yeah, I got 5 errors, and all of the other timings are like exactly the same, except for TRP and TRC, right? Because I was like, maybe it's TRP, so I'll tighten TRP, I'll raise TRAS, TRC, and if it errors out again, then it's got to be TRP at that point. But yeah, it didn't error out for like a full day of Carhu, so that's cool. And it didn't error out in White Cruncher, and it didn't error out in Prime 95. Though now that I've stopped it, we can't see that, which is why I was like, yeah, you can see all the workers are still running. CPU temperature maxed out at almost 100 degrees because yeah, 9950X runs pretty hot because unlike most of the other 9000 series CPUs, it doesn't have super strict power limits, so it can get very, very hot. I do have a fan pointed directly at the memory sticks, so the airflow washing off of the memory area is keeping the VRM like ice cold. It's just at 56 degrees Celsius. And the memory sticks are at like 40 because the fan is actually tied to the CPU temperature, so it was going. Funnily enough, the memory fan is not the loudest fan in the system. It's the GPU. Because the GPU I'm using is a Radeon Pro WRX 3100, and that's like an old workstation card with one of those little blower fans. And yeah, that little blower fan, the bearings on it seem to be a bit shot because it is very rattly. Yeah, it's not exactly like a whooshing sound. It's just more like a scratching sound from that fan. And the reason I'm using that is this motherboard doesn't want to initialize my GT 1030 in the primary PCIe slot, which is super weird. Like it'll initialize the GT 1030 off of the chipset, but not off of the primary PCIe. No idea why. But anyway, so yeah. I just find that kind of funny because the thing is the fan that I'm using is a fan off an AMD stock cooler, and the blade shape on this combined with the fact like it doesn't actually spin that fast, and the blade shape is very gradual, so it doesn't really get that loud even at full tilt. So yeah, I can't say I've really like now that I've stopped Prime 95, I don't think I really noticed much of a difference because the GPU is just so much louder than the memory cooling, which is kind of stupid, but oh well. Also, yeah, the CPU fan maxed out at like 2700 RPM, which with that blade shape, yeah, is just not that loud. Anyway, the memory stayed at, and like, relatively speaking, ice cold 40 degrees on the hub temperature. So that's cool. Not really that surprising because, yeah, the heat spreaders that Kingbank has on these memory sticks work pretty well. And I'm not running them, like, we're on an AMD CPU, admittedly a dual CCD, so it does put more stress on the memory than, say, a 9800 X3D would. But there's no RGB on these memory sticks, which helps with the cooling as well. So, yeah, these tend to run very cool. So that's nice. There's no errors in hardware info, and the PHY RDLs are matched, both 36. So again, just A channel PHY RDL 36, B channel 36. Interestingly enough, this motherboard actually trained 36 on auto settings, which was surprising because in my experience, most motherboards at 6400 on auto will train 3638. So I'm not sure, like, maybe that's a sign that, like, the board's memory topology is a bit better or something, but that would need more testing. But yeah, I think that's, like, the first time I've seen that a board just trains 3636 on auto. So that's cool. Other than that, I'm running the Nitro timings at 121. I kind of considered trying 120, but I wanted to get this over with soon. So, yeah. Also, it's worth noting with the Nitro settings, these vary a lot from CPU to CPU, which is like a recent-ish discovery for me because, for comparison, the 9800 X3D I have absolutely hates trying like 121 or even, I think even 131. Like, it basically only works at 231. Which isn't the end of the world, but it is, like, out of all of the timings that you can adjust, these actually make quite a difference. So, yeah, is that everything I wanted to show in the OS? Think so. Yeah, so now we shall go into the BIOS. I'm just going to take a screenshot before we do that. And, yeah. Oh, no, grab the wrong thing. Grab the wrong thing again. OBS, why are you so... Damn it! There, postcode. Oh, also I did try disabling gear down mode, but that immediately just sent stability, like, it wouldn't pass even like a couple percentage points of Carhu. Are you kidding me? I think this GPU doesn't want to go into the BIOS. Oh, you've got to be... Wait, that doesn't make any sense, because... I did all the memory... Okay, so... What do you mean out of range? Oh, it's because the capture card is 4K. Oh, that's so stupid. Wait, I wonder if I can boot it. I hate making videos. It's just like, you always end up with some stupid problem. I'm hoping that if I initialize it on the monitor and then I switch it to the capture card, it'll stay in 1080p. And it did! Yay! Okay, so I don't have to, like, use a different display output. Cool. So here we are in the BIOS. And, well, one thing you might have noticed was that I did actually adjust the TRC-DWR timing as we were running 28, 16, 38, 34, 126. And the thing is, in this version of the BIOS, which is F4A, which is the latest beta BIOS for this motherboard, you do not have a TRC-DWR timing in the main settings. And in fact, you might be looking at this portion of the BIOS and going like, Buildzoid, why is everything set to auto, yet your timings are like adjusted? Well, we shall get to that. But before we get to that, I have the FCLK set to 2133 because that has a slight, like, this is a bit faster than like 2166 at 6400. Depending on the workload, it's potentially slower than 2200. The thing with running 2200 FCLK is that it's kind of a pain to verify the stability, and I prefer not having to deal with that. So 2133 it is. UCLK equals MCLK, so we are in 1-to-1 mode. SoC voltage just set to 1.3. This is a little bit on the high side for the CPU, I think. Like, it could probably run this as 1.21, but I don't know how the, SoC voltage regulator on this motherboard behaves, so I'm erring on the side of caution with a little bit more SoC rather than a little bit less. And for the sake of stability, right? Obviously, from the, like, power consumption perspective, less SoC is better. Anyway, then for the memory voltages, VDDIO at 1.4, VDD at 1.6, and VDDQ at 1.4. The VDD might be a tad high for CL28 at 6400, but with a fan pointed at the memory sticks, I don't really see a point in trying to minimize the VDD voltage. 1.6 volts is not going to harm the memory sticks, so yeah, don't see a point in, like, I don't see a reason to worry about that. So anyway, now let's go take a look where I actually configured all of the memory timings. Now, I would generally recommend that you that you don't do it this way. But I wanted to mess with it just cuz, and when I realized like, oh, this is another motherboard that doesn't have TRC-DWR easily accessible in the BIOS, I was like, okay, we'll just do this the hard way. Welcome to doing your memory timings the hard way. So, here in the DDR timing configuration section, I have Expo turned on, but you'll notice I have the memory speed set to 6400. And then, and then active memory timings I have enabled, which is one of the reasons why I have to have like Expo turned on over here. And then DDR SPD timings. So what you'll notice is these timings look a bit weird because they've got letters in them. Yeah, these are all in hexadecimal. Which is not the end of the world, it's just really inconvenient, as you kind of have to have a calculator to convert between the two. Now, the Windows built-in calculator does this, but obviously you'd need like a second PC to do that, so let me just quickly... I should have prepared this ahead of time. Bam. So, yeah, this is the default Windows calculator. And so you have the decimal option, and it automatically converts to hex. So if we take a look at, for example, this right here, which is my TRC-DWR, so that's currently set to 10, which in decimal is 16. And that's why it's called hexadecimal, is because 10 is 16. And then like A is 10, B is 11, and yeah, like for smaller numbers, it's not that big a deal. Like 1C is 16 plus 12, so that's 28, right? Because C is 12, and 10 is 16, so it's 16. Yeah. Anyway, so you'll just want a calculator for converting between the two, right? Like I wanted for setting cache latency is like, oh, I want CL28, so I get the calculator to convert 28 to 1C for me. So yeah, that's rather inconvenient. And the thing is, like, this section of the BIOS, like, the idea is that the main timing section that in the tweaker tab from Gigabyte, like, that is supposed to do the translation from decimal to hex for you. Just Gigabyte didn't implement the TRC DWR setting, so yeah, I decided to mess with this for once. Again, I would like it's not that big a deal. It's not that hard to convert between hex and decimal, right? Like like you literally have software that does it for you. It's just annoying. Um, but yeah, you know what? I guess I'll keep the calculator up because I can't read these myself, so you know. So anyway, yeah. So cast latency set to 28, TRC DWR set to 16. That's this one. Also, you need to like turn on manual control, right? Because otherwise it's just auto. But yeah, so that's set to 16. Then we obviously have 38, which is 26. That's this one over here. 22 is 34. That's TRP. TRAS is maxed out at 7E. 7E. So that's 126, which is kind of a funky register limit, to be completely honest, because, I mean, it kind of makes sense. I guess it's like 2 to the 7, or like close to 2 to the 7, if I remember correctly. Yeah, it's close to 2 to the 7, so that kind of makes sense, but, anyway, then we have TRC at 3A, which, doesn't, like, I didn't test 54, but I tested 52, and I didn't test 56. But 52 was very unstable, right? That errored out in like 4 hours of Karhu. So that's obviously not an option. Maybe 54 or 56 would have worked, but in terms of performance impact, 54, 56, 58, they're all going to perform kind of the same. Like in the video I did about how TRAS and TRC on AM5 behave a bit weirdly, I did show that TRC actually has significant, like, does boost performance, but usually that was like dropping TRC from like 60 to 30, right? So that's like a huge jump in TRC. And I didn't bother testing like 2-tick increments because there's nothing to measure in that kind of scenario. It's just not going to show up in any benchmark with any uh, measure of like consistency. So you're just, you know, like if you're seeing performance differences, it's basically the software being inconsistent rather than the timing actually affecting anything when you're making adjustments that small usually. So unless you're like doing getting unstable or something. So yeah. So I'm not like maybe 54 or 56 would have worked, but they would have performed the same as 58. So 58 is good enough. TWR is at the limit. Now, I think TWR, when I first set it to 30, like didn't apply properly or something. But yeah, like now it's working. So it might have just needed to be like booted twice or something, because I don't. It's also possible that I just like typed it in wrong or something. So yeah, because I remember like booting up once and being like, why is my TWR not at 48? Which is just like the TWR I use for basically every Hynix memory chip. I've just not had any issues running TWR at 48 on any of the Hynix memory kits that I've tested so far. So, yeah. Anyway, then we've got TRFC1, which is set to 220, which is 540. This is a little bit on the higher side for 24 gigabit MDI. But generally it'll bottom out somewhere between 170, 160 nanoseconds. And 554 is, if you divide that by 6, no, 544 divided by, no. Oh, I can't do 3.2. Well, that's stupid. Yeah, but that's 170. 170 nanoseconds. So alternatively, like 512 would probably still work. Like a little bit above 500, somewhere. Like that should be the lower limit, but the refresh interval is maxed out. So, you know, when your refresh interval is 65,544 cycles every 65,000 cycles, just doesn't matter that much in terms of performance. So 544, in my opinion, is like a nice safe option for TRFC values on 24 gigabit MDI. TRFC2 and TRFC same bank, I did not adjust. These are just the auto values because neither of these do anything. And RTP is set to 10, which is 16. A little bit on the higher side, but Generally with RTP, I prefer to run low TRP rather than minimizing RTP. And if you try to push RTP as low as possible, it can negatively affect how low you can set TRP. I want to do a video like actually showing that in practice with some 8i sticks, because yeah, I have some 8i sticks where it's like super obvious. So anyway, TRDL set to A, which is 10. It's the one I do remember. So yeah, that's just 10 right there. 24 gigabit MDI just doesn't usually do TRDL quite as low as 8i. Now, at 1.6 volts, it probably could have run 8, but 10 and 8 also kind of perform the same, especially on TRDL. It's not like TRDS. Like TRDS at 10, kind of a big deal. TRDL at 10, not a big deal. Pretty much doesn't matter. So yeah, anyway, TFall set to 20, which is 32. Which, yeah, it doesn't make sense to set TFall lower than that when TRDS is set to 8. And we have WTRL at 16, which is just what I like. That's the like safe option in my opinion for WTRL on Hynix memory chips, and then WTRS at 4, which is the same thing. That's like, you know, if I'm not trying to push a Hynix kit to its absolute limits, 16 and 4 for the WTRs is just kind of what I go with. And it works on basically every kit that I've tried so far. So, especially at these lower like speeds at 1-to-1 mode. Though honestly, even in 2-to-1 mode at like 8,000, 16 and 4 usually work. So, yeah. Anyway, so that's part 1 of the timings, and then we got part 2. So here we've got the back-to-back, read-to-read SCL4, read-to-read SC1. I've seen a few instances of people setting this to values other than 1. Never do that, okay? It tanks performance. Never, ever, ever set TRDSC to anything other than 1. Okay? Like, just don't. Anyway, write-to-write SCL set to 4, write-to-write SC set to 1. Also, if you're wondering why like SD and DD over here, these are on auto, this is a single rank memory setup. SD is for the other memory rank on the same memory stick. These memory sticks don't have another memory rank on them, so that doesn't do anything. And DD is for a different DIMM, so that's the other ranks on the other memory sticks on the same channel. But I don't have other memory sticks on each channel, right? Like each channel only has one memory stick on it, so DD doesn't do anything either, and there's no reason to adjust it. So yeah, same thing with these two down here. Write-to-write SCL set to 4, write-to-write SC set to 1. Funnily enough, write-to-write SCL doesn't really do much of anything to performance, but I just set it to the same thing as read-to-read SCL because, yeah, that works. Hasn't caused any issues. I've seen some people set it to 1. I've seen some people set it to really high. I just like setting it to the same thing as read-to-read SCL because, yeah, that's like nice and consistent. Not that it like I've tried measuring if that makes a difference, and it just kind of doesn't. So, which I suspect the main reason for that is that Ryzen CPUs just do not have the necessary memory write bandwidth to be able to like test the performance impacts of this timing. Anyway, write WRD set to 4 and RDWR set to 16, and then the refresh interval completely maxed out at 4 Fs. So, yeah, 65,535. So, anyway, so basically, like, this is memory timings that I've run on, like, Hynix 24 gigabit MDI a bunch of times before. I'm just doing it on a different motherboard from usual and setting it from the most awkward part of the BIOS possible. So, yeah, the timings themselves aren't really anything special. The only reason I'm actually going through all of this, like setting all the timings with Hex, is because of TRCDWR, which isn't accessible in the main menu, by which I mean like the tweaker tab. And like, while TRCDWR does make a measurable performance difference, I shouldn't say noticeable because humans aren't that sensitive, but if you run some memory benchmarks, TRCDWR does make a difference. More of a difference than I thought it would. But yeah, where was it? Oh, there. And since I was already here, I was like, okay, I'll just set all of the timings from here. Because, like, I wasn't sure if there would be, like, some weird conflict if I had some of the timings set from this menu and some of the timings set from the tweaker menu. So I did all of them. Again, I don't really recommend that you actually do this way. You can. It's certainly doable. It's just kind of clunky. So, but it does work. Anyway, other than that, DDR-PMU training, I do have this set to 2, but like I mentioned earlier, this actually isn't necessary. The reason it's currently set to 2 is I was messing around with like setting it to 1 and 0, and that would train 34 and 6. I was really hoping I could get it to train like, because when I saw that, hey, 3 trains 36, 36, and 2 trains 36, 36, I was like, well, maybe if I set it to 1, it'll train 34, 36, and if I set it to 0, it'll train 34, 34. Except it didn't. It just trained 34, 36 again. So, yeah, that's kind of annoying. Yeah, so after messing around with that, I just raised it back up to 2 and left it there. So that's that. Then for the Nitro settings, I have 1 to 1. I didn't adjust any of the training options. Didn't see a point in doing that. Power down is disabled, but that gets disabled by default. I didn't adjust that myself. I think that's just like if you turn on Expo, it probably gets disabled. Is there anything else I'm forgetting? No, Nitro timings, Phi RDLs. Oh yeah. I did try turning off. Wait, where is it? Oh, it's in here. Yeah, so I did try turning off gear down mode, but that makes the stability just disappear instantly. And I tried a little bit to try fix that. Didn't really make much progress on that in like half an hour, I think. So I gave up on that. Yeah, I don't think that makes enough of a difference to justify the effort. At least not right now, because I did want to get this done sometime soon. So, I think that covers everything. It's like, yeah, if you wanna mess with your, oh, I did also, I think I enabled the SoC OC mode manually, and that just disables like power savings on the memory, like some more power savings on the memory controller and Infinity Fabric, which can help with stability sometimes. Yeah, like so. Anyway, is that everything? Yeah, and then this I just left it on auto because the predictive mode should, like, it might be more stable, but it should make the performance worse. So, yeah, I need to do some testing on that, but for now I'm just going with like I usually just leave it on auto anyway. So that isn't anything different from what I usually do. It's just I haven't actually like tested what the other option does. Anyway, I don't think I adjusted anything. Yeah, didn't need to adjust any of the like VDDGs or anything. Like Gigabyte sets them reasonably on auto, so no reason to change that. There's no reason to mess with VDD MISC because, well, if you were trying to run very high VDDGs, then you'd need to adjust VDD MISC. But I'm not trying to run super high VDDGs, so there's no reason to mess with that. And yeah, and then the load line calibrations, I've left those on auto because I don't have a way of checking to see what's actually happening with the voltage. I don't have the oscilloscope hooked up to the motherboard. So, yeah, I think that's it. Just a, like, in my opinion, easy overclock. Actually, technically an underclock, right? Because this is a 6800 CL34 kit. Yeah, just a easy like first initial setup to like get a feel for the motherboard, or more like check if there is anything like really weird early on, with this board, and there isn't. I have another, like, there's a like, I already have plans for, like, probably gonna run the 9800 X3D with a different MDI memory kit and try some 2-to-1 mode stuff, because obviously this 9950X is useless for that. But yeah, so 1-to-1 mode on this board works as expected, which is not surprising, because I don't think I've run into a single motherboard where 1-to-1 mode doesn't work as expected, right? Like, we are doing 6400, but that's mainly down to the CPU. Like, this 9950X, it does 6400. I have other CPUs that will never ever run 6400. Or even if they do run 6400, they need way more SoC voltage to do it than this CPU does. So, yeah, the fact that this is running 6400 1-to-1 is not really, like, that's not the motherboard being special as far as I'm concerned. That's just the CPU. Yeah, like, the main point for, like, you know, the other thing was also messing with all the timings in the hexadecimal version of the BIOS settings. And yeah, so that can be done if you're really desperate to get, you know, access to the TRCDWR timing. I don't really think it's worth the effort, but I mean, it's not that bad. But, like, yeah, if you're not comfortable with doing the, like, using the calculator to convert all of your timings from decimal to hex, then you should probably just use the tweaker tab instead. Anyway, so hopefully this is somewhat helpful or interesting or whatever. And yeah, thanks for watching. Thanks for watching. Big thank you to the channel supporters for funding the purchase of the motherboard and the CPU. If you'd like to support the channel, there are links in the description. You could check them out. That would be very much appreciated. And that's it for the video. So, thank you for watching, and goodbye.